Welcome back to the meadow census. Today, we're measuring two traits for each goose, wingspan on one side and weight on the other. Look at this scatter plot mapping wingspan against weight. The flock becomes a drifting cloud of points leaning uphill. When a cloud trends in a straight band, lay a straight line through its heart, balancing points above and below to build a predictive model. Let's check a scatter plot of hours studied versus quiz scores, clustered upward. A straight line models this relationship because the points show a roughly linear, positive association. This single line summarizes the trend, doing its job even without passing through every single point. A straight line is useful here because the data shows a roughly linear, positive association. It summarizes a complex reality into a single, clear direction. Here is the line of fit for that scatter plot, written as an equation: y equals 6x plus 40. What exact quiz score does the model predict when the number of hours studied, our x variable, is exactly 5? Pause the video, substitute 5, and calculate the prediction yourself. Using the line equation, we substitute 5 for x. This gives us y equals 6 times 5 plus 40. 6 times 5 is 30. 30 plus 40 is 70. The line predicts a score of 70. That number is an approximate prediction of the overall trend. It is not a guarantee that a specific student who studies for 5 hours will score exactly a 70. Take a look at this new scatter plot. Notice how the points curve sharply upward as the horizontal value increases. Would a single straight line be an effective modeling choice for this curved dataset? A straight line changes by the same amount for each increase in x, mandating a constant rate. But this curved data behaves differently. It changes slowly at first, then accelerates rapidly. A straight line completely misses this changing rate. A single straight line is a poor model because the association is curved. You must choose models based on what the scatter plot actually supports. We can see a clear contrast in this split screen: the successful geese model on the left and the poorly fitted line on the right. The key rule for any predictive model is that the line must faithfully follow the overall trend of the underlying data. Recognizing when a line of fit makes sense builds directly on your understanding of scatter plots and prepares you to interpret real-world linear models with confidence. So the next time you drop a line through a scatter of data, ask yourself one question: does your line follow the overall trend?